instruments or measuring calibrated devices are available. You can use any one for measurement of force using any kind of measuring method. So that's one. That's the definition is force is maybe defined as the measure of the gravitational attraction. Remember, the gravitational attraction between masses. Next, come to the point, the very important, being a mechanical engineer. So how do you carry out a force measurement? Say force can be measured by using two methods. One is direct comparison, other one is indirect comparison. So in direct comparison, it's everything is direct. For that, a good example is analytical balance. You have already used in the chemistry lab, and also you might have seen in the outside in the grocery shop or provision shop. You have seen the analytical balance. That is the nothing but a beam balance. All of you seen the in the vegetable market, they use the two pans which is connected to the beam. So that is nothing but a beam balance method. So beam balance means when the two pans and the beam which come to the symmetrical position, that is the measurement. So very good example is the analytical balance which you used in chemistry laboratory, and also the weighing machines used in the vegetable shops. So that's the very good example for direct comparison. Next, come to the point, indirect comparison. So here you have two or three or more translations. Two or three or more translations are present in conversion of the unknown force into the measurable one. So like that, in the indirect comparison, there is a translation. From that, you can measure the force. For that, good example is the electronic weighing machine. So in this weighing machine, what will happen? If you keep anything, any mass or sugar or anything on the platform of the electronic weighing machine, what happens? What happens? The unknown mass exerts the force on the platform. The platform is connected to the strain indicator. That is the electrical resistance strain indicator. If you keep something on the platform which directly affects the characteristics of the strain gauge, that is nothing but the change in the resistance. That change in the resistance can be measured by using simple current sensitive circuit, or you can use Wheatstone bridge. So here the force is converted into analogous signal. Again, the analogous signal is converted into voltage signal. Then the voltage signal is converted into digital signal. So that digital signal is converted into grams or in kgs. That's the very good example for the indirect comparison. Next, come to the point. All of you studied the analytical balance. You already performed experiment in the chemistry lab. That is the analytical balance. Here, the very important concept of analytical balance is beam balance. Beam balance. That is nothing but when the three positions, all of you observe here, W1. Here I have written steel yard mass. Instead of writing steel yard mass, you write down metric dead weight. Metric dead weight, W1. On the right side, that is unknown force. That is the anything, any material or any item which is placed on the pan provided in the analytical balance. And the center, you have a dial. On the right side, on the left side of the dial, you have 10 graduations. When this dial come to the zero position, that is nothing but null balance. That is the exact weight of the unknown force which is placed on the right side. So this is the procedure for measuring unknown force by using analytical balance. This is the explanation. This is the explanation for analytical balance. Next, come to the point. Very important. All of you mark it very important. This time you can expect this question. Suppose if you have already taken the question in the last class, no problem. Some of them not yet present in the last class. Now you can write down the question. Please, all of you, write down the question. This is very, very important. You have this question in the 5th module. Almost all the question paper, you have this question in the examination. Without this question, there is no question paper at all. So for that reason, all of you, please write down the question. Suppose if you are not taken in the last class. Now, write down explain briefly with the need sketch, explain briefly with the need sketch the multiple lever system, or platform scale, Put a question mark. Continue the question. List the applications. And limitations. Put a question mark. Continue the question. Derive the expression for force measurement using platform scale. All of you mark it. Very, very important. Next, come to the point. What all the parts or what all the components present in multiple lever system or platform scale? First, come to the point. The name itself indicates platform. So here, all of you observe here. You have a platform here. The dimension of the platform may be 2 feet by 3 feet or 3 feet by 4 feet. Like that, the width and the length of the platform is very, very large when it is compared to the conventional weighing machine used in the grocery shop. The application of a multiple lever system is you can buy 10 kgs or 1 kgs to 1 ton. That is the range you can weigh using the platform scale. So the width of the platform may be 2 feet and the length of the platform is 3 feet or 3.5 feet. So on that, you can keep the 50 kgs bag or 100 kgs bag or 10 kgs bag. You have accurate result. Next, come to the point. The beam. See, this is the beam, and the end you have a weight. You have a hook in that, or the something just like a rod in that. You can place the poise weight. So along with the platform scale, manufacturer supply the poise weight that is in the denomination of 10 kgs, 20 kgs or 50 kgs or 100 kgs. Like that, they supply the poise weight. WS 10 into 2, 20 into 2, 100 into 1, 500 into 1. Like that, he supply the poise weight, and the end of the beam there will be a provision in that you can place the hook along with the rod. So in that you can place the twice weight according to the measurement. And then come to the backside of the beam. It looks like a crane hook, and come over here. Here you have a movable voice weight. Movable voice weight. So for example, if you want to measure 43 kgs, 43 kgs, then what you have to do? You have a voice weight in the denomination of 20 kgs, 10 kgs, like that. You place 20 kgs into 2 voice weight here, then it becomes 40 kgs, and move this movable voice weight on the graduation near to the 3 or after the 3. So when this beam deflects inside the place between the platform scale, there will be a provision to oscillate the beam up and down in the platform scale. So when the beam moves upward direction, the weight of the bag is less. Weight of the bag is less. Then add the item to the bag. Then add the item to the bag. Then if the beam comes to the bottom direction, that indicates the weight of the bag is more. That is, for example, you are measuring 43 kgs. The bag weighs more than 43 kgs. So in that, what you have to do, by trial and error method, remove the item or add the item so that the beam comes to the exactly in the center of the place provided for the oscillation of the beam in the platform scale. That is the exact weight of the bag which contain 43 kgs of item. This is the procedure used for measuring of unknown magnitude or unknown force. And next come to the point. Say here you point O, which is placed on the knife edge, and next come to the point, the end of the beam, which is connected to the tension bar, the tension exerted by the weight of the bag, that is measured in terms of T, uppercase letter T. This is called tension bar. And the backside of this tension bar, there will be an adjustable counterpoise. Say, before weighing or before measuring the force, adjust the beam to read 0 by moving the adjustable counterpoise in clockwise or anti-clockwise direction, by turning the weight provided in the backside of the beam, or that can be moved forward direction or backward direction. By turning clockwise or anti-clockwise direction, bring the beam to read 0, that is null balance. Then come to the point. This point is connected to the lever. All of you observe here. This is the lever, main lever. And before that, next come to the point. Here, all of you observe here, weight W. The bag contains 43 kgs of item. Keep the bag on the platform, anywhere on the platform. Remember, all of you, anywhere on the platform. That is the advantage of using platform scale. So you can place the bag on anywhere on the platform. You will get accurate result. You will get accurate force measurement. That is the advantage of using platform scale. So all of you observe here, W. This is W, and this is W1, W2. That indicates you can place the bag or unknown magnitude anywhere on the platform. That will give you the accurate result. W equal to W1 plus W2. That is the platform scale. This is the platform scale. If you keep the bag on the platform, which exerts the force on the back lever, all of you observe here, there will be a lever which is hinged at one point, which is hinged at one point. Other point is free, which exerts the force on the main lever, which exerts the force on the main lever. Again, the main lever is hinged at one point. The main lever is hinged at the one end of the lever, and the other end is connected to the tension bar through the trapezoidal knife edge. All of you observe here triangular shape, that is nothing but triangular trapezoidal knife edge. The tension bar placed on the triangular knife edge on the beam as well as on the lever. So whenever the force is exerted by the back, there will be a pull in the downward direction. Due to that, the beam oscillates in the place or the hole between the upper position and the lower position and the center position. That is the oscillation. So where you can measure the unknown force when the beam come to the exactly at the center. That is the exactly at the center. That is the weight of the unknown magnitude. Unknown magnitude. So this is nothing but weighing the unknown force using platform scale. Once again, the principle of operation of platform scale is keep the bag containing any item, say for example 43 kgs of rice, place it on the platform. Then that weight exerts the force on the lever, this lever, and this lever is hinged at one point, the other end is free. This end exerts the force on the main lever, exerts the force on the main lever. This main lever again, which is hinged at one point, the other end is made free and connected to the tension bar and connected to the tension bar. As the force exerted by the bag containing 43 kgs of rice, which makes the tension bar to move downward direction. All of you observe here the arrow mark. All of you observe here the arrow mark, which indicates this tension bar moves up and down by pulling the beam in downward direction as well as in the upward direction. And the poised weight, the movable poised weight can be moved according to the weight of the bag. So for this example, 43 kgs, test the poised weight of 20 into 2 on the hook provided in the poised weight, and the movable poised weight to near to the third graduation or third line. See that the beam moves up or down or at the exactly center. By adding the rice or removing the rice, see that the beam come to the center position. The place provided for the oscillation, it should come to the exactly at the center position. That indicates the weight of the bag, which contains 43 kgs of rice. 43 kgs of rice. So this is the principle of operation of multiple lever system or platform scale. Next, come to the point. This is the explanation. All of you observe here. Say in this diagram, you have to mention a distance A, B, C, D, E, F, H. All of you observe here a distance in this diagram. A, B, C, D, E, F. There is no G, H. A to H. These things are very, very important. If you mention all the points A to H in the diagram, the examiner understands that you know the concept of multiple lever system. Say this type of weighing machine you can see in the wholesale vegetable market and wholesale mandi, and also where you can weigh more than 100 kgs or 200 kgs or up to ton is possible. So that is the advantage of using platform scale. Next, come to the point. So there will be a derivation, that is force into distance, perpendicular distance. The tension is T and the distance is B, and the force Ws and the distance is A. In the same way, you have force into perpendicular distance. All of you go through the equations 1, 2, 3, 4, and finally you can substitute the values here. W equal to A by B into C by H into Ws. That is equal to R into Ws. R is the scale multiplication ratio that is used for adjusting the lever to read 0. Lever to read 0. So you have a doubt why it is called multiple lever system. Remember, it contains the platform scale contains number of levers, or which contains number of levers. See, all of you observe here. There one is lever, another lever is present, and see, you will not see the other side of the platform scale. Few more levers are present. So for that reason, which contains more levers, for that reason, it is called multiple lever system. And this is the example. That is the force into perpendicular distance. This is the tension T and the distance P. That is the force by Ws and the distance A. In the same way, derive the equation 1, 2, 3, 4, and finally find out the value of W, that is equal to A by B, A divided by B into C divided by H into Ws, or into Ws. Ws may be, say in this case, in this example, Ws is 20 into 2, 40. So for that reason, R is required for the total weight. That is R equal to A by H. C by H is the scale multiplication ratio. That is W equal to A by B into C by H into Ws. That is WP. And the W, you have to calculate the W by using relation. By using relation, you can calculate the unknown weight. Unknown weight. So this is the explanation and the derivation for force measurement using platform scale. And you have proving ring. So that I will do in the next class. Now I stop at this stage and I will continue in the next class. Now I make unmute to all. Ganesh, can you listen? Hello? Ganesh? Kevin?
Yes, sir.
Ganesh, so I have not prepared the important questions. Tomorrow I will prepare the important questions. I will give in the next class, please.
Sir. Yes, sir.
Okay, now stop at this stage and I will continue in the next class.
Yes, sir.
Okay, thank you.